Okay, class, we're about to start section 9.1. It says, number one, a blank has no length, no width, and no height, but it does have a location. It is represented by a dot and is usually labeled with capital letters. Draw an example below. It's a point. And an example would be like so. That's an example of a point. Or we could do a point on a number line. Let's just say this is A. We could say this is B. And we could put our point here at B. Okay, now it says number two, a blank is a set of points extending indefinitely in two directions. It has no width or height, but it does have length. We can name it by any two of its points like AB or by a single lowercase letter, usually L. Draw an example of CD below. So this is a line. And an example of CD, this is an example of line CD. Okay, now we have a blank is a piece of a line with two endpoints, usually labeled by its endpoints AB. Draw an example of BE below. This is a segment. It basically looks like a line, except for at the end, it has points. There's no arrowheads at the end. So then we would draw an example, B here, E here. This is an example of BE. Okay, number four. A blank is a part of a line that begins with some point, say A, and continues forever in one direction. It is labeled by a starting point and any other point it contains. Let's see, AB. Draw an example of JK below. Okay, so now this is array. Now, one other thing I need to go back and do here. When we drew the line here, I should have put a point here on C and a point on D. Okay, now we go here, we want to draw array. So we'll draw our endpoint here, draw our line, or the half of the line, and then a point here. So this would be J, and this would be K, and this is array. Okay, and blank is a figure formed by two rays with a common endpoint. The common endpoint is called the blank. It's an angle. And it's called the vertex. Now, it says note that when you name an angle, the vertex is the middle point. Please refer to the purple box. Now, this is in the textbook for more on naming angles. Draw an example of angle EFG below. Okay, so remember, it's two rays. So we'll draw one ray going this way, with our endpoint. And then we'll draw another ray this way. Now, we had 3 points. Now we got a point here, we need a point here, and we need a point here. And our angle is E, F, and G. Okay, so now it says draw an example of angle EFG. Now, if we were solving this, we would mainly be looking at what angle F gives us, and that would be our answer. Now we go down here to number 6. Match the term to its definition below. Okay, now, I don't have enough room to show everything at one time, but we will go through and try and figure everything out. Okay, an acute angle. Now, an acute angle is angles whose measures are greater than 0 but less than 90. That is an acute angle. So what I'm going to do is I'm going to box this up here so we'll know that this only goes with this here. Okay, now, a supplementary angles, we have to scroll down here. It's angles whose sums is 180 degrees. That is a supplementary angle. So this will go all the way down here to the bottom. Oh, for some reason that broke off, but okay. I just, oh, it's not letting me do it here, but I'll box this up. So this goes with this here. Now, we go back here. We have right angles. Now, a right angle we know is an angle that is 90 degrees. Now, it says here angles whose measures is 90 degrees. So that is a right angle. Now, I don't know what happened here, but let's go here with this complementary angle. Well, let's go here. It came back. It's a straight angle. Okay, now a straight angle is angles whose measure is 180 degrees. And then we have complementary angles, which is angles whose sum is 90 degrees. Now, for some reason, this isn't scrolling, but you all could do this on your paper. And then finally, we have the obtuse angles, which goes up here, which is angles whose measures are greater than 90 but less than 180. And that is it for this portion. Now, we scroll down here to number 7. It says in the figure below, which are the vertical angles? Now, we know vertical angles go straight up and down. Vertical is straight up and down. Okay, so now, this is what we need to do. One other thing you need to know is vertical angles are also equal to each other. So, what we would do is this here. I'm not going to use a protractor here. So what I'm going to do is I'm going to tell you that imagine that angle 1 is equal to 96 degrees. Okay, now if you look here at angle 1 and angle 2, if you take this line out, if you took angle 1 and angle 2, the two angles added together would be a straight angle. Wouldn't this be just a straight line? And yes, it would be. And we know straight angles equal 180 degrees. So what we would have to do to find out what angle 2 is, we would take x, which would be angle 2, plus the 96 degrees, and it's supposed to equal 180 degrees. We would subtract 96 degrees on both sides, and we have x is equal to 84 degrees. So angle 2 would be 84 degrees. Now we go here with angle 2 and 3. Wouldn't that be a straight angle if we take this line out? So that means that angle 2 and 3 added together must equal 180. So it'll be x plus 84 is equal to 180 degrees. We'll subtract 84 degrees on both sides. And we'll have x is equal to 96 degrees. Now angle 3 is 96 degrees. Now if you look at angle 3 and 4, they form a straight angle. So what we would do is, we already did the x plus 96, and we found out that that would be 84. So angle 4 would be 84 degrees. Now if you look here, the vertical angles are equal. This is 96 and 96. This is 84 and 84. Now we go down here, angle 1 is 96 degrees. Angle 2 is 84 degrees. Angle 3 is 96 degrees. And angle 4 is 84 degrees. Now let me say this early on. I just made up the 96 degrees for angle 1. And typically in the problems that you will have, you will be provided either with one of the angles, or you will have to take a protractor and find out what the angle is equal to. You do not make up the value of an angle. Let me repeat that. You do not make up the value of an angle. I just did this for the sake of the problem and because I'm making this screencast here. But let's scroll down. Now it says write a statement about the relationship between vertical angles. Vertical angles are congruent, which basically means equal. Okay, now it says translate the following mathematical statements into words, then use a protractor to draw and label each angle. Now again, I'm not using a protractor here, but what we could do is I could draw a sketch here. Now we have, this is the measurement of angle ABC is equal to 45 degrees. Now we could write out 45 degrees, or you could just write the number. Okay, now a visual representation of this would be, now we know, let me go off to the side. We know this is about a 90-degree angle here. Of course, it's not as straight as I would like it to be, but this is about a 90-degree angle. So we need to take about half of that. So we could do this. This is about a 45-degree angle. Okay, now they want us to label it, so we could label this. You know, this would be A, this would be B, and this would be C. Now we labeled this. Now we have the measure of angle A is 90 degrees. Now we could say the measure of angle A is 90 degrees. Now that was really close. Let me try it again. I think actually this is closer. Now, this is the 90-degree angle, and we can mark angle A here. This is angle A. So that's the measure of angle A is 90 degrees. And we could draw our little arrowheads here. Okay, now we scroll down here. It says using a ruler or a folded piece of paper to help you draw two parallel lines. Now we know two parallel lines never intersect. I'm going to try my best to draw as best up. Well, actually, we do have these figures here that I could draw. Let's see if I could find it. Let's see, shapes. Okay. So there's one line. I could go back to these shapes. This is a good representation of parallel lines. Now we want two perpendicular lines. Two perpendicular lines intersect and they form 90-degree angles. So I just draw one line here, and I could draw one line here. Now you can either have it go through, or you could just have them stop. It could be like this. Sometimes you have perpendicular lines. Well, actually, since it said lines, we would just leave it as this. This is a representation of perpendicular lines. Now it says find the measure of angle X in each figure. Now there's an assumption here. There's an assumption that this whole angle here is 90 degrees. So that means that angle X plus 27 must equal 90 degrees. So we'll subtract 27 degrees on both sides. So we have X is equal to 90 minus 27 is 63 degrees. So X is 63. Now we come to B. Now this is assumed to be a straight angle, and we know 42 degrees plus X must equal to 180 degrees. It's supposed to be plus X equals 180 degrees. We subtract 42 on both sides, and X is equal to 138 degrees. And that's the final answer.